First, let's read the problem together and summarize the most important information. In 2001, EPA adopted a lower standard for arsenic in drinking water that applies to both community water systems and non-transient, non-community water systems. The new arsenic standard is 10 ppb. What is the highest molarity of arsenic in drinking water approximately at 20.0 degrees Celsius that can meet the standard of EPA? The density of pure water is 1.00 gram per milliliter at 20.0 degrees Celsius. As you may have already noticed, I assign a symbol to every number and every number with a unit. I also assign a symbol to what we are looking for. If you assign appropriate symbol to the numbers with units, it will be easier for you to find the equation to use because all equations contain symbols, not numbers. Now let's conduct some analysis. Let's see what kind of calculations we need in order to calculate the molarity of this problem. The first thing we are looking at is the definition of ppb. I use 3 lines to represent this is the definition. ppb is defined as the mass of the solute divided by the mass of the solution, multiply 10 to the 9th power. Let's look at the definition of molarity. Molarity is defined as the moles of the solute divided by the liters of the solution. As we have already learned in class, when we convert one concentration to another concentration, we can assume we have any amount of the solution. We can also assume we have any amount of the solute, but do not assume both at the same time. Now I'm going to assume we have a certain amount of the solution. If we know how many grams of the solution, because we already know the ppb is 10, we can find the mass of the solute. Our solute is arsenic. It has the symbol of As. The unit we are going to use is gram. As we can see here, if we assume we have 10 to the 9th gram of solution, our calculation of the mass of the solute will be super easy. So let's make our calculation easy. So we assume we have 10 to the 9th gram of the solution. If we know the grams of arsenic, which is the solute, we can convert to the moles of solute, which is arsenic, by using the molar mass of arsenic, which we can look up from the periodic table. We already know the mass of the solution. If we know the density of the solution, we can convert to the volume of the solution. Because 10 ppb is a very, very low concentration. So we can safely assume that the density of the solution is approximately the same as the density of pure water. After we find the moles of the solute and the liters of the solution, we can plug into the definition of molarity, then calculate the molarity. This is our step 1, step 2, step 3, step 4, step 5. Now let me show you the details of all steps. Step 2. We will calculate the mass of the solute. The ppb is 10. We are looking for the gram of arsenic, which is the mass of the solute. And we already assume we have 10 to the 9th gram of solution. The gram of arsenic will be equal to 10 because 10 to the 9th power, 10 to the 9th power will cancel. Step 3. We will convert the mass of arsenic to the moles of arsenic. From the periodic table, the molar mass of arsenic is 74.92 gram per mole. If we plug these two numbers into a calculator, we will get 0.133 moles of arsenic. Step 4. We will calculate the liters of the solution by using the mass of the solution and the density of the solution. The volume of the solution is 10 to the 6 liters. Then we will plug in the moles of arsenic and the liters of the solution into the definition of the molarity. We will calculate the molarity. Can you follow my example to work out this problem by yourself?